Welcome back to Edu-Malanga. Thanks for tuning into our channel where we do videos for South African mathematics syllabus. What we're going to be continuing on today is functions and inverse functions. I'll be doing an example of functions. Again, if you remember correctly last week, we learned how to differentiate what a function is, the relationships of functions, and also, very, very important, to draw the function because you're probably going to be asked to plot out the function in the exam. So let us start. I'm going to write for you an example here. Okay, draw the graph of x is equal to 2y squared and determine whether or not this is a function. So guys, my handwriting is a function. It's not the most legible, but I think that, comment below if it's too bad. I'll change the pen, but should be good enough. Okay, so what we were given is the graph of 2y squared. I think just to the naked eye, this doesn't look like what we're used to seeing, but we still need to plot in different values of either the domain or the range, domain being x, remember that, and y being the range, so that we can decipher whether or not it is a function and what kind of relationship we have. Already we're seeing squares, so there's probably a many function somewhere and not just a one-to-one function. But let's go and decide what it actually is. So I'm going to substitute in a 1. So y is equal to 1, right? Y is in the range, it's not in the domain. Remember, don't confuse this with x. And then what we get is going to be getting 2 times 1 squared is the same as 1 times 1. So 2 times 1, you can do this on your calculator or you can calculate it. So essentially we got 2. And we're now going to substitute in negative 1. Okay, squared, we get the same thing. Okay, negative 1 times negative 1. Discussed it last time, the negatives become positive. 1 times 2 is 2. So I'm going to plot this for you guys here on our Cartesian plane. For anyone who doesn't know what a Cartesian plane, it is an x and a y axis drawn as I am drawing it. This is the intercept, so we'll call this 0, and at every line we have 1 point. We're going to move in increments of 1, and none of our numbers are too big, so that is not an issue. I'm going to plot at x is equal to, at y was equal to 1. So y is equal to 1, I have x is equal to 2, so I'm going to move to 2. Okay, and then here, at x is equal to negative 1, I get also again, so at x is equal to 2, sorry, y was equal to negative 1, so y negative 1 is down here, and we get x down here. And then if we were to substitute in a 0, we know we would get 0 because of the relationship, because there's no constant number. So what we get is a graph that looks like a sideways parabola. Okay, there's 2 tests I taught you in the previous video, and one of the tests is to decide whether it is a function or not. If we go back to our question, it says draw the graph of x is equal to 2y squared and also determine if this is a function. So for those that remember, we said a function is where we just draw simply a vertical line. And so what we get here is we get places where the graph is not being crossed just once but twice, so therefore it is not a function. However, okay, what we see displayed here is not necessarily, if I had to draw a horizontal line, I wouldn't necessarily get a many to one function, but a one to many. But if we look carefully, we see that again, the relationships are not one to one, okay? Because we're getting the same value for different values of y, and therefore this relationship graph that is not a function is a many to one relationship. Okay, so now I'm going to do an example that's more comprehensive, has a lot more going on. So let's enjoy, guys. Given, okay, the graph or relationship or function, okay, x squared plus 2. So this is the relationship that we're given, and these are the questions. Determine. I think sometimes when I'm trying to write fast, I don't write the neatest, but you guys are free to comment below, because I would love for this to be as legible as possible. F at 2, f at negative 2. So we're told to go and substitute these values of, yes, the domain or x, and use their values to draw the graph fx. This is the relationship fx, this is the graph of fx that we're going to draw. So the second one is using the same graph, okay? Use the graph to decide the type of relation that fx represents. So we're going to use the graph to decide the relation. I'm not going to write the whole sentence down, as long as you guys understand the question. So we're going to use the graph and whether it is a function or not, okay? And whether it is a function or not, okay? And then 3. We haven't done this yet, but we've been discussing it, and so I think we will be able to handle it very well. Write down the domain, x values. What are the x values and range of fx? Okay, so we're just gonna give it to them, because we've been doing this and we trust you guys so much, and I know if anyone can do it, it is you guys. Okay, so the first thing I'm going to do, I think this is very important for you guys too, is that we rewrite our function, simply because it's so easy to forget the function and start writing 2x or something. 2x or something like that, even though this is the function that you're given. So it's very important to write it down. You know what I mean? They cannot take away marks for you rewriting the function. Fx is equal to x squared plus 2. The first question was to determine f at 0, f at 2, f at negative 2, and to use these values to plot this graph. Okay, so f at 0 is equal to, again, I'm going to put it in simply. I think I encourage this method, but if you're confident, please, I will not rain on your parade. Just write it out, write it fully out, and don't get yourself confused. 0 squared, 0 times 0, 0 times 1, 0 times anything, is 0 plus 2 is equal to 2. 2 squared is 2 times 2, which is equal to 4, plus 2 is equal to 6. Negative 2 squared, negative 2 times negative 2, the negatives cancel, so we get a 4. 2 times 2 plus 2 is equal to 6. So I'm just going to plot these on my plane. Okay, I think I'm going to draw it a bit down, like, just because I can see that the numbers are pretty large. I'm just going to draw it like that. But same thing, guys, same thing. All it is a Cartesian plane, and I take this as 0, 1, 2, 3, 1, 2, 3. So, okay, so what happened at f is equal to 0, which is x was equal to 0, I got a y of 2. So at x equal to 0, I got a y of 2. So I'm going to draw it Write it out, write it out, write it out. At f was equal to 2, 1, 2, I got 6. So 1, 2, 3, 4, 5, 6. So that was at, okay, 2, 6, and then also at negative 2, I got the same 6. Okay, I think people are already thinking, it's our many. And they're already thinking, yay, it's a function. But we're not about rushing things. I'm just going to draw this here for you guys just for visuals. But essentially, we would have now gotten the marks for question 1, which was to draw out the graph. Use the graph to decide what kind of relation it is. Okay, so you saw I drew the graph. I'm going to redraw it again for you guys, just so that it's here, just so that we're sure. We don't want to play around. Sometimes I think in maths there's easy marks and we need to get them. If it's easy, it's easy. You know what I mean? Hard marks, okay. But easy marks, we can't play around. So we're just going to make sure we redraw it. And there we are. Okay, so I'm going to now draw again just my decoration, my vertical line here, and my horizontal line. Essentially, we know that this gives us an indication of whether or not it passes the test. So, about it being a function, we can already see it crosses the graph only once. Okay, so yes, it is a function. So, one place, a dotted line, cuts graph. My handwriting is even changing. Can you believe it? A horizontal line test, and what we see with that is it crosses twice. So what kind of relation does this have? I think this is so important, and I think it's nice just to write it down, but it's so important because it tells us whether it's a straight line or is it a parabola. What kind of shape is it? Okay, so what we see here is there's many x values, so as negative 2 and 2 give us the same value, so we're getting a many to one relationship. Okay, then the last question was determine the domain and the range of the function. I think again, because you have it already, you can flip back in your exam sheet, or if you're me, you redraw, because we cannot lose easy marks, guys. We cannot lose easy marks. Just redraw the function there for you. And we remember over here we were sitting at negative 2 and 6, negative 2 and 6, and here we were sitting at 0 and 2. I'm just going to write it down. And here we're sitting at negative 2, 6. So what we know to be the domain is x values. Cannot express it enough. Is that you've just got to take it as it is. So if we look at our graph for clues, already we can see the x values go all the way there, all the way that way. And so essentially it is all real numbers. Is that understandable? All real numbers, because all of these constitute of x values. So we're not looking at y values, we're looking horizontally. This essentially means it goes on till until. Okay, so the domain of the graph of f, this is how we write it, is x, is all elements are real numbers. Essentially, you can memorize this. It just means that there is no limit to what x can be. Okay, the range, however, as we see here, there's nothing going on. So everything above 2 and 2 itself is the range of f. Okay, the range of f therefore becomes there is y values, just like this. You write it like that. Elements, real numbers that are greater than and equal to 2. So 2 is the small number, everything above. So all real numbers satisfying this. I'm going to write this down for you guys just so that we understand. All real numbers satisfying this relationship, this condition, okay, are part of our domain. So what we have here, ladies and gentlemen, is a finished question. You would have answered the question of drawing the graph, whether it is a function or not, how the relationship looks, and the domain. Thank you very much. Join us next time for example 2 of functions. I'm also just really interested in what you guys have to say, so please comment at the bottom, especially if, like, my twos, if my twos are just a bit, slanted, so we can discuss that. But essentially, we're here for maths. We're here to change the narrative around maths being hard. We're here to get us through maths, and we're here to support one another. And yes, we'd love to engage with you, and we'd also love to continue making content. So for us to do that, please like, subscribe, share, and come back and ensure that if you did not understand this topic properly, you rewatch the video, you do the examples, and you interact with us. Thank you very much.